working at Contera now for 5 years. At some point I got the professional and trainer certification. Most of the times I'm doing trainings and spot consulting for customers. Yeah, and why I'm here is to give a short introduction what to do if you are working with FME and you get to its limit. It's really hard. You have so many transformers, so many formats available. It's really kind of hard to find use cases where you do have to code your own, to use Python code, but when it's very easy because it's very good integrated. So yeah, what's Python? So I could just read it out and the 20 minutes were gone, so just forget it. Let's give it a short run. So Python is an interpreted language. You don't have to compile it, you don't have to link it. Everyone who uses perhaps C++, Java knows he writes his code, and he switches to his compiler, compiles it, he has an executable binary, and then he can execute, and then his program works. Or you have to manage linkages with some third library to get it working. It's really hard. So in Python, you can just start, you open your Python interpreter, you write one line code, and it gets executed at once. Then it's dynamic typed. So you don't have to declare your variables before to say A is now a container for strings or numbers, or A does hold numbers. You don't get those type exceptions. Python manages that for you. So you have the A is Tino, and then it works. And it has a very extensive standard library. You find for every purpose, you can find something in the standard library. And when the standard library is not enough, there are thousands of free libraries on the web. You can just download them, put them into your local Python interpreter and use them. So most of the time, if you do coding, even with FME, is go to Google, you have a problem, you go to Google, you search for Google, and either you go to Stack Overflow to find your code, you get pointed to any library which you can use. So it's much more copy and paste than you think. Yeah, and very important, it's available without charge for all major platforms. So if you do Python coding with FME, you don't have to worry if it's later run perhaps on in the FME cloud on Linux, or if you use FME now on your Mac. It's available on all platforms. And it's available for 32 and 64-bit, so no worries there. Yeah, and it's freely distributable. So Safe is able and can include its own, their own Python interpreter to FME. So I can just do a quick demo here. You can use FME. I have a small hello world script here, and I can just use FME hello world. So you don't even have to install Python on your computer if you have FME. So here you see prints hello world. You don't have to install any additional software on your computer. Yeah, so it's really included. It's included in FME server. Just start, write some lines of code in your Python caller, or any of the other ways I will show you later, and start coding with Python. So why use Python? Besides it's integrated, it's very easy to learn. So I've never used Python before. I started working with FME 4 or 5 years ago. I was a Java developer from university, and it's really, compared to other programming languages, it's really very easy. So it's, I really like it. It's very Googleable. So just type in Google Python your problem, and you find a solution in 95%. The thousands of additional libraries for every purpose. And it's very fast. I don't think I've ever experienced performance issues when I use Python code in FME workflows. So it's still, all the feature handling is done in a very native way. I'm sure C++, C, or it's ever used to implement FME, and the Python is only a wrapper around it. So you just use the Python, and you can go to all your attributes, manipulate features. It doesn't make your process slower. And you have a very comprehensive usage. If you learn Python for FME, you can also use it with many other projects. Esri, ArcGIS includes it. Blender is an open source tool. And because it's freely distributable, many software firms do include Python in their products. So this is your first line of code, or actually 2 lines. The hashtag signs, it's a command, it's my code, hello world, and it's just a print statement to put something on the screen. So this is a very famous hello world example. It's used in every language to show the first steps to, and of course it just prints hello world on the screen. And perhaps programmers here will notice you don't have to declare a class or a function, an entry point at some point. You can just enter it. So here I start my Python interpreter. It's not very beautiful, it's a console. So I can just here print hello audience. And it does get executed. So no compiling, no linking, just coding. It's very good for rapid prototyping. So what can you do with FME with Python in FME? The first thing is start up and shut down scripts. Whenever you want to do something before your actual FME process run, use a start up script. Whenever you want to do something when you are finished, when your process is finished, when all features are written, use a shutdown script. And you find it in the navigator in FME. It's a bit hidden. You have to go to the workspace parameters, advanced, and then you have the start up Python script and shut down Python script. Yeah, that's the first thing, and it's really cool because when you code in the shutdown script, you can access several parameters from FME. You can access the runtime, how long did it take to run your process, how many features got written, and so on. You can access all those variables, and of course you can check if your workspace finished with a success or failure. Very important if you want to do some notifications based on the result of your workspace. Yeah. So this is my first live demo. We used it for a customer who didn't use FME server, and he had several FME processes running on a regular basis. He included them by a batch file in the Windows Task Explorer, but he wanted to have a more easy way to monitor the result than have to every day look up the log files of ME and check what's the result of the processes. So we did a shutdown script, which we have included in all his workspaces. And this shutdown script writes the results into an Oracle database after each process. So he has one table in his Oracle database where he can check easily what are his processes doing. So this is a live demo. Switch to my FME process. So this here. So this is just a demo. It's not the live workspace to make it easy. I'm just doing a simple translation from MapInfo. It's a Park data set. Perhaps you know it from the demo. And for demo, I converted to shape and to GML to have two output data sets. So let's have a look at the shutdown script. And you see it's not matched, it's only an import. So the target was we want to use the same script in many workspaces. So we didn't script here directly in the workbench. We wrote our own Python file, which contains the script. And in all workspaces, we just have to do the import. So if we want to change something, we just have to edit one Python file, and all workspaces will use it for their next runs. So let's have a look. This is my do statistics. So, and because I don't have an Oracle database available here on my local computer, I just changed it to write it to a text file. So we can have a live look here at it. What we are doing, we import, most important perhaps here is we import the new FME module. This is one new module introduced with FME 14, which gives you access to many statistics in FME, and it's available in the shutdown script. So just ignore this here. This is for now. It's open the CSV file, and I append here to aggregate all my runs. And here you see I accessed FME point total features read. So the number of total features written by my process. Read by my process written, elapsed runtime, peak memory usage, and then I add some more information now on my computer name and my username. So if you deploy this in a company environment and many FME processes run on different machines, you can have one central statistics database and look up all the processes. So I will run this. Doesn't take too long to write those parts. Okay, time. And let's have a look at the resulting file. Demo 1, statistics. So because I've run it sometime before, we have already an entry with, oh yeah, last evening I did a test. So I've here the status is true, 22 features read, 44 features written. The runtime, it's my Menotti is my computer name, my user shortcut, and I've for the entry. I will run it once more to, here it is. And you'll see another entry will be appended to the file. Of course, in real time, we have used just an Oracle database to store it. So this is just for demo purposes. And then another entry. So one usage case for Python FME, if you perhaps don't have an FME server available. Yeah, the next thing, of course, is the Python creator and Python caller, two transformers in FME where you can use Python to manipulate your features in your workflow, in your FME process. So you can see the only difference is the Python creator has no input because he creates features, and the Python caller has an input and an output because you get, of course, your features in your workflow, manipulate them, and perhaps if you want to, can output them. Of course, you can also do filtering, so decide, depending on your Python code, which features to process further, perhaps some features you want to discard at some point. So the number of entering features and the number of leaving features of a Python caller doesn't have to be the same. So this is already also a live use case. In one project, we wanted to handle features with an arbitrary number of attributes. So the source data, all the features had attributes, many different attributes, and that a destination schema was very strict. So here, for this example, I say my features in my target schema only want to have the attributes name and ID, so those I want to copy, and all other attributes shall go into an attribute container. So it's just an additional table in our database, and we take the reference ID of the feature, the attribute name, and the attribute value. So this is something you can't do with FME transformers. There are only some transformers which can do work on all attributes. So perhaps you could think it's doable with a bulk attribute renamer, but you can't do this special task. So again, I show just the workspace. Again, it's only testing data. I create some features, and you see my feature has a bunch of attributes. And after it runs through my Python caller, I will only have name, and the ID is coming here from my feature creator. And let's have a short look at the code. So it's some lines more of code. But here you can very easily, you can get all attributes of a feature via a method, and then we iterate over all these attributes, check if they are in our do not map list, so these attributes stay on our objects, all other attributes go into our attribute container. Run it, it goes into the data inspector. You see I do here a test. So one feature gets into my Python caller, 5 features leave. So it's on my one main feature and 4 attribute features which go into my container. Oh, it's seeable. So that's my original feature. So you can see it has only ID and name as attribute, and all other attributes which I created before go into my attribute container. So we have only one feature, so our reference ID is always null, and a bunch of attribute names and attribute values. Okay, next thing is scripted Python parameter, which also were introduced only a few years ago, 2011. This is very cool if you want to get user input. So I think everyone knows published parameters, but you want to do something before you use this published parameters. A use case we have used several times is you want to create a where clause for database access. So perhaps a date stamp. So the user shall enter a date and you only get those features which are newer. And it's a bit difficult because you don't want to have the user type your whole where statement into the published parameter, where my date is smaller than, so you can take just a scripted Python parameter, ask the user for a date in a very easy standard syntax, and then use one line of Python code to put this user entered string into the whole where clause, or produce a whole where clause and use that for your perhaps Oracle or MySQL reader to get the features from the database. So, and as you can see, it's very easy. The one constraint for a published Python parameter is you have to return a value. So it's just return something, and this is the value you can use in a transformer reader writer to process it in your workbench. So if you want to use some more libraries, often it's easier in FME to use your system-wide Python interpreter. In my case, we are doing many projects with ArcGIS, and ArcGIS comes with its own Python interpreter. So I got just to FME tools, FME options, and change the runtime. And then when I use Python script in my FME, I can use ArcPy, which is a ArcGIS Python by library. And of course, you can do it to use other Python versions, because the default Python interpreter of ME is version 2.7. Perhaps you are using other software, or you're stuck with Python 2.6, and then you can just use this in FME. This is the order of evaluation when you do. So this was the first thing what just gets interpreted is the Python parameters, then the Python startup script. So if you have computed something with a scripted Python parameter, you can already use it in your Python script. Then when the Python startup script is finished, the workspace logic begins. So your reader starts and your features get processed. And last thing is then shut down Python script. So sometimes it's important, and one thing is scripted Python parameter already are evaluated in the order of how you define them in the workspace. So you have, if you want to use one Python parameter and the next, you have to put them in the right order in your workspace, but you can change the order just like your reader order in your workspace in the navigator. Yeah, so a last demo, it's just a short demonstration. Of course, you can do Python scripts and use FME. So use the FME objects, and one simple new thing is, it was introduced last year, is a workspace runner interface. Before that, you had to do the OS library of Python or the sub-process library to get a FME process started from Python, but there's no a dedicated interface. It's the workspace runner interface, which gives you several methods to execute workspaces. So you can run a workspace, you can run a workspace with parameters, and even you can prompt and run. And this is something I will show. My script is here. So it's just 5 lines of code. I import the FME objects module. So this is just here to show which version I use, so I don't need to start a session. And then I make a runner. So this is the workspace runner, and I run my workspace and print a job done. So I use prompt and run, then because so this results when I now run this Python code. Oh, that's where's my dialog? Just a second, I have to restart it because of a changed network environment. seems to be a bug in the idle IDE. If you change environments, it can't connect to its own sub-process. This one, my VPN connection was lost. Damn it. How many? 2 minutes? Oh, it's
Keep going. You're almost there, right?
So it's very usable because it's much more flexible to write some Python code to do batch processing with FME than to write batch script, at least in my experience, because perhaps I am more used to Python. So recent files, demo workspace for now. Okay, here is this again, one module. So it takes my FME 2014 ready to work. And you see there is even a UI. It's a pop-up which asks me the published parameter. It's the same. You can have a look at the workspace. This is this one. If I use it in FME, I have one defined published parameter, and my Python system comes up and asks me, oh, say hello to FME geeks. So now Python starts my FME workspace, runs it, and it should put up. It's like just a simple demo. So all redirected to the data inspector. And here, welcome to the FME UC, FME Geeks. So I just created a text object, geolocated it here at the Vancouver Convention Center, and the data inspector showed it. So it's a very simple use case, but it shows how to run workspaces from Python. And of course, this workspace runner interface gives you programmatic functions to access the published parameter. So you can say, so give me an array of what published parameter has this exactly workspace, and then you can fill it. You can ask for what's the default value of this parameter, and then you can fill those values in programmatically and run your workspaces. Yeah, so then I will skip this. You can even with Python, so the plugin SDK has advanced in the last year in many ways, so you can even code your own transformers in Python. There's a sample available in the latest beta. It is also possible with FME 2014, but there is no sample included. And if you want to have a further look at the API documentation, it's in your FME home directory, but you should have installed your FME with a selected option, install SDK. When you install FME, you are getting asked if you want to install the SDKs. Select yes, and then you have the full API available. So thank you for your patience. I hope you get some ideas how to use Python with FME.
All right, so we got a couple minutes for any quick questions we have in the audience. And I have one request before you leave. If you can take a feedback form from me and just drop it off with us sometime today, just to say what the session was about. All right, the question here.
Yep. So what's the difference between the import FME objects and the import FME?
Different use cases. The FME module is only available in a shutdown script. So if you have Python code contained in a workspace file, so there are only statistic variables available. The FME objects give you access to the whole FME functionality. You can, it's used if you want to include FME functionality in your own product or code. So if you code some JIT software on your own and you want to have include FME, you want to use FME objects. If you want to get FME statistics in FME, you use the FME module.
With the Python shutdown script, does it still run if the translation fails?
Yeah, it's executed always. And you can just use if FME dot, I think it's FME result, to execute different code if it either has failed or it was successful.
Any other question here?
Do you know if the FME code can handle Python 3?
It can
No, not at the moment. So it's I'm not sure what if there are plans to.
Yeah.
But
I'm not a Python guy.
no.
So check out FME Doctors upstairs. And
but Python 2 and 3 are not that different. So I'm also stuck with 2 because S3 uses 2. They will switch to 3 with ArcGIS 10.3 or Pro. Not sure how they will name it. I think perhaps next year SAFe will switch to 3. But all the code you do in Python, it doesn't matter if you're using 3 and 2. And they even extended the support lifetime of 2 to 2020. So you will get bug fixes and security releases of Python 2.7 until 2020. So there's much time left to migrate.
Okay, I think that's probably enough for questions for now. If anybody wants to get in touch with Tino, I guess either come see us
I'm around here.
upstairs and we can get in touch.
I'm sure there are some people here who join me on my training on Friday. So there's a whole day training session on Friday where we do, you can learn this or the whole day. We will all do this, what I've shown here on Friday, more specific. And if you are later at home, we have done a webinar last year. It's available on YouTube in the SAFe channel, me and Christian, who is sitting in the audience. It's a 1-hour webinar where we have demoed some of these use cases. You can just watch it. And of course, Python FME Basics, it's a good entry in the FMEpedia to get started with this. There are many examples and code samples to use it in FME.
Okay, great. Thank you, Tino. You guys can grab these.